For the most effective use of this film, we want you to imagine that this boy is fully life-size and at a distance of about 10 feet from you. Our comparisons of size and distance will start with this scale. Where does the universe begin and where does it end? How large are we in relation to our universe? Who are our neighbors in cosmic space? This film shows two important physical concepts: the relative distances and the proportions of size to be found in space. We will take you on an imaginary journey out through space to the edge of infinity in one direction and then back to the nucleus of the atom in the other. The universe is not only all around us, but is also within us. The atom, in relation to man, is roughly comparable to man in relation to a star. In order to acquire a cosmic view of space, we need a framework on which to build our knowledge. We must, therefore, give strict understanding to the meaning of scale. As we move outward, each leg of our journey will take us 10 times farther away and uncover 100 times the area of the preceding position. Later, we will move from the human body to the atoms within. On each leg of this journey, we will move 10 times closer and enlarge the area 100 times. To measure distance, a new square will appear whenever we move 10 times farther away from or 10 times closer to the previous position. To indicate the scale of reduction or magnification of each scene, numerical proportions will appear. The small numbers after 10, known as exponents, refer to the number of zeros to be added. This is the short and practical way to express long figures. For instance, light travels at the approximate rate of 6 trillion miles per year. It can be written 6 times 10 to the 12th power. Incidentally, this is known as 1 light year. We see a girl living in a small town of Central California. The scale is life-size, or 1-to-1. That is, a foot on the screen should represent a foot in actual life. We move upward 10 times with each shift of scene. The area coming into our field of vision increases 100-fold, while each new image is on a scale 1/10 of the preceding. When we reach a height of 2 miles, most of the hometown of our girl comes into view. On this scale, 1 foot on the screen should equal 1,000 feet in actuality. We move away from the Earth at increasing rates of speed, for our journey into space covers tremendous distances. We are traveling at 25,000 miles per hour, the speed necessary to escape the gravitational pull of the Earth. We continue to accelerate. And all of California comes into our field of vision. Contrasts of color, size, and shape, which are apparent to the human eye, tend to diminish at these distances. We see the Earth as a limited dwelling place, surrounded by darkness. Through the silent emptiness, we accelerate outward to the limits of human knowledge, 2 billion light years away. The orbit of the Moon and the orbit of the Earth come into view. We continue to accelerate and are now exceeding the speed of light, 186,000 miles per second. The Earth eventually becomes invisible to the human eye. The orbits of Venus and the other planets, together with the elongated orbit of Halley's Comet, come into view. In reality, none of the planets would be visible at this distance. We would simply see a star, our sun, around which they revolve. It would take light 11 hours to travel across the orbit of Pluto, the farthest planet of the solar system. This is a distance of over 7 billion miles. On this scale, man would be the size of an atom. We are now 1 light year from the Earth. This means that in our imaginary journey, we have traveled at an average rate of 186,000 miles per second for an entire year. We must realize it is quite possible that numberless other suns, with their planetary families, are moving through the emptiness of space. To avoid confusion, we omit from these pictures many background stars which are not of our immediate neighborhood. Our nearest star, Alpha Centauri, is 4 light years away from our Earth. A circle encloses all stars within 50 light years of our sun. At this distance, the sun is no longer visible to the naked eye. On this scale, the sun would be the size of an atom. 1 foot on the screen represents about 100 light years. As we move outward to approximately 30,000 light years away from our Earth, we leave our own galaxy, composed of about 100 billion stars. Viewed from Earth, our galaxy appears as the Milky Way. In one spiral arm of our galaxy is located an invisible speck, our solar system, which revolves with the galaxy once every 200 million years. The universe is composed of hundreds of millions of galaxies, which have a tendency to form clusters. For this vast distance, science does not yet provide us with precise data. With our finest telescopes, Our knowledge at present extends to some 2 billion light years away, or 12 billion trillion miles. We are able to see, certainly, far less than what in actuality exists. Our universe extends far beyond the limits portrayed on this screen. All that we have seen may be as small as a grain of salt compared to that vast expanse of the universe which is yet unknown to us. Now let us return from the boundaries of outer space and investigate the minute realm of inner space by moving closer and closer to the body of man until we reach the nucleus of the atom. Once again, we begin with a scale as close to life size as possible. 1 foot on the screen should equal 1 foot in actual life. We will move closer to the face, the eyes, and the skin of our girl. We place a grain of salt to give relative proportion. Each new scene will represent a scale 10 times greater and an enlargement of the area by 100 times. A circle represents an average human hair in scale with each scene. As we move closer, the grooves of the skin become clearly visible. The salt crystal and the hair are magnified 100 times. At a scale of 1,000 to 1, we observe the smallest known unit of life, the cell. Groups of similar cells form tissues. Blood vessels and sweat ducts are also seen through the microscope. We are in the final domain of scale, wherein the human eye can obtain an impression of color. The smallpox virus is detected by the powerful electron microscope. On this scale, the salt crystal would be the size of a house. The starch molecule and the infantile paralysis virus begin to appear within the square. At a magnification of 10 million times, we note air molecules. On this scale, the average distance between them would be the breadth of the United States. We also see the sodium and chlorine layers of the salt crystal. Finally, we approach the nucleus of the sodium atom. The darker shading indicates the probability of finding one of the 11 electrons somewhere within the sodium atom, revolving at speeds of almost 700 miles per second. The vastness and emptiness of space here is comparable to the distance between the sun and her planets. Our journey ends at the nucleus of the atom. Science cannot yet determine the utterly minute orbits of the neutrons and the protons within. On this final scale, a man would be 10 times larger than the diameter of our solar system. Through this imaginary journey to and from man, we have found life as we know it to exist in only a small segment of space. Life may also exist on other scales, infinitely smaller or larger than those we can conceive today. Future scientists, exploring beyond the presently known limits of space, may perhaps find that all of space, as we know of it, is but a dot in an infinitely larger universe. But for this moment, our globe is our limited dwelling place and our immediate neighborhood. On this little grain, lost in the vast sands of time and space, we are fashioning the tools for actual journeys into the mysterious realms of the universe. Stars and atoms. Somewhere midway between these two extremes stands man with his own world, less than a speck in a corner of the infinity of space.